Chapter 10. Force, Work and Energy, the Dynamic World. In this lesson, force, types of forces, work, energy, forms of energy, simple machines, lever, inclined plane, pulley, wheel and axle, screw, wedge. What do you observe when you look around you? You see a variety of moving objects like cars, buses, people, birds, etc. Some objects like chairs, tables, trees, etc. are not moving, they are stationary. Force can change the state of motion, thus, force and motion are closely connected. Force is defined as the push or pull that changes the state of a body on which it acts. Examples are kicking a ball, opening a door, a mother pushing a baby pram, etc. Force can move a stationary object, e.g. pushing a cart, move an object faster, e.g. pedaling a cycle faster, stop a moving object, e.g. catching a ball, make a moving object slow down, e.g. applying brakes, change the direction of motion of a body, e.g. hitting the ball with a bat, change the size or shape of a body, e.g. stretching of a rubber band. In other words, force can change the speed and direction of motion of a moving body. It can also change the size and shape of a body. Types of forces. Forces are of different types. Gravitational force. Gravitational force is the force by which objects pull one another. It attracts objects towards the earth. When we throw a ball, it always comes back to the ground due to the earth's gravity. It is because of the gravitational force that we are bound to the earth. Otherwise we would be floating. The earth and other planets move around the sun in fixed orbits due to the gravitational pull of the sun. Muscular force. Muscular force is the force applied when we push, pull or lift something. It is the force exerted by our muscles. Frictional force. Frictional force tries to stop or slow down a moving body. We are able to walk, drive a car and run because of frictional force. A moving ball comes to rest on its own because of friction. It is harder to walk on smooth, polished surfaces because the friction is less. Without friction, we will slip and will not be able to walk. Elastic force. If we apply force on an elastic band, it stretches. It returns to its original size when the force is removed. This is due to the elastic force which arises when a body deforms. Mechanical force. Mechanical force is produced by simple machines. Mixers, cars, buses, etc. move due to the mechanical force produced by motor/engine. A pair of scissors cuts cloth using mechanical force. Buoyant force. When we push down a hollow plastic ball into a bucket full of water, we feel an upward opposite force on our hand. This upward push of water on a floating object is called upthrust or buoyant force. This force acts on every object when it is put into a liquid. When you enter a swimming pool, you feel lighter as the buoyant force of water lifts you up. Work. According to science, work is said to be done only if the force applied on a body causes the body to move in the direction of force. Examples are picking a ball, pushing a cycle, lifting clothes and putting them in a cupboard. However, no work is done if you stand in one place with a heavy bag, even for an hour, though you will feel more tired than if you have kicked a ball. Energy. Energy is the capacity of the body to do work. That is why we eat food to get energy for various activities. There are different forms of energy. Energy is present everywhere in nature: sunlight, wind, water, animals and even plants. We need and use energy every day. Forms of energy. Mechanical energy. Mechanical energy is possessed by a body due to its position or motion. It is of two types: kinetic energy and potential energy. The energy possessed by a body due to its position, example stone on a wall, is called potential energy. Thus, potential energy is the stored energy of position. Moving objects have kinetic energy. Thus, kinetic energy is the energy of motion. For example, a moving ball, flowing water, a child walking, etc. Heat energy. we get heat energy from the sun or when we burn fuels such as kerosene, wood, etc. This energy is used in steam engines, power plants and for cooking. Light energy. We get light energy from bulbs, tube lights, burning candles, and also the sun. Light is nature's way of transferring energy through space. Electrical energy. Electrical energy is a form of energy we use when we light a bulb, tube light, or use any appliance that runs on electricity, computer, television, washing machine, refrigerator, etc. Electrical energy is the movement of electrical charges. When electrical charges move through a wire, it is called electricity. Magnetic energy. Magnetic energy is possessed by magnets. Magnets are able to attract iron objects. Solar energy. The energy obtained from the sun is called solar energy. It is used by plants to produce food. We use it to dry clothes, to cook food using solar cookers and heaters, and to heat water. Solar energy is the most readily available source of energy. It is also a non-polluting source of energy, and thus the energy source of the future. Nowadays, there is more emphasis on producing electricity by using solar energy. Wind energy. Wind is also a plentiful, widely distributed, clean source of energy. Windmills are used to convert wind energy into a useful form. Wind turbines in a windmill convert wind energy into electricity. Hydropower. Hydropower is the power generated from moving water. It is the most commonly used energy source among all renewable energy sources. It is one of the oldest energy sources in use. It was in use thousands of years ago to grind grain with a paddle wheel. Dams are built on rivers to generate hydropower. Sound energy. Sound energy is the vibration transmitted through a solid, liquid or gas. When a force causes an object or substance to vibrate, sound is produced. Some common sources of sound energy are radio, music system and musical instruments. Geothermal energy. Geothermal energy is the heat energy obtained from within the earth. Geo equals earth. Therm equals heat. The heat and steam produced inside the earth can be used to generate electricity or to heat buildings. It is a renewable energy source since heat is constantly produced inside the earth. Law of conservation of energy. Energy can neither be created nor destroyed. It only changes from one form to another. For example, when you throw a ball, your muscular energy gets converted into kinetic energy of the ball. A moving fan converts electrical energy into mechanical energy, rotational movement of fan. Simple machines. A machine is a tool which makes our work easier, faster and simpler. Simple machines apply force at a suitable point and change the direction or the amount of force applied to make the work easier. When we use a machine, we have to use less energy and effort to perform more work. There are 6 different kinds of simple machines: lever, inclined plane, pulley, wheel and axle, screw, and wedge. Lever. Lever is a simple machine used to lift heavy weights with minimum effort. It is a rigid rod fixed at one point called the fulcrum. A lever has 3 parts: load, fulcrum and effort. Load. The object to be lifted by the lever is called the load. Fulcrum. It is the fixed point on which the lever turns. Effort. The force applied on the rod to move or lift the load is called the effort. If we have to move a big stone with our hands, it will require a lot of force. But if we keep a small stone, fulcrum, under the rod near the stone, and apply a downward force, effort, at the other end of the rod, the stone, load, is lifted easily. A lever thus reduces the effort to do the same amount of work. Levers are divided into 3 classes, depending on the position of the fulcrum, the load and the effort: first class, second class and third class levers. First class lever. In the first class lever, fulcrum is in the middle, and load and effort are on either sides. Examples: scissors, trolley, seesaw, pliers, etc. Activity. Take a wooden ruler. Balance it on a pencil by placing its center on it. Now try balancing the 2 sides with coins. The pencil acts like a fulcrum. This will work exactly like a seesaw. Second-class lever. The load is between the fulcrum and the effort in the second-class levers. Examples: wheelbarrow, nutcracker, bottle opener, etc. Third-class lever. The effort is between the fulcrum and the load in the third-class levers. Examples: tongs, fishing rod, stapler, etc. Inclined plane. An inclined plane is a sloping or slanting surface used for making work easier. It is easier to push or roll objects down an inclined plane, rather than lifting them up. It also helps to lift objects to a height. Examples are children's slide, ramps for wheelchairs or stretchers in a hospital, sloping road, etc. It is easier to climb a mountain using a winding road rather than making a steep climb due to this reason. Pulley. A pulley is a simple machine having a wheel with grooves in it. A rope or a chain is wrapped around the wheel. One end of the rope is attached to the load. Force is applied at the other end. We use pulleys to draw water from a well, hoist a flag or draw curtains. Pulleys are of two types: fixed pulleys and movable pulleys. Fixed pulleys. In a fixed pulley, the pulley is fixed on some support. It does not move. A rope is passed over the fixed pulley and a load is attached to the other end. Fixed pulley helps in changing the direction of the effort required to make work easier. Lifting of water from wells and hoisting of flags, flagpoles, are examples of fixed pulleys. Movable pulleys. In a movable pulley, the pulley moves with the load. Examples of movable pulleys are cranes. Movable pulleys are always used with a fixed pulley to lift loads. Wheel and axle. In this, a wheel is attached to a rod called the axle. The wheel is usually bigger than the rod. When we rotate the wheel, the axle attached to it also turns. Effort applied to the wheel helps in turning the axle, and vice versa. Examples are screwdriver, steering wheel of a car, pencil sharpener, doorknob, bicycle wheel, sewing machine, etc. Screw. A screw is a series of inclined planes wrapped around a cylinder in the form of a spiral. Screws are commonly used to hold things together and lift materials. Carpenters prefer using screws to nails as screws hold things tightly and they do not separate easily. This is because the screw holds two things together through a longer distance, the total length of screw threads, while a nail holds things together through a shorter distance, length of nail. Example: screw jack is used to lift cars, bottle lid, furniture like revolving chairs, etc. Wedge. A wedge has two inclined planes which meet at a sharp edge in the shape of a V. Examples are blade, knife, axe, chisel, etc. All big machines are combinations of some of these simple machines.